Dear students, let us continue with the next topic, types of optical fibers. Optical fibers are classified into three types based on the materials used for making optical fibers, number of modes transmitted, and the refractive index profile. The three types of optical fibers are step index single mode fiber, step index multimode fiber, and graded index multimode fiber. So let us study about each of them. Let us begin with the step index single mode fiber. So in the step index single mode fiber, we have the geometry of the fiber, refractive index profile, and the ray propagation. So let us know first about the geometry of the fiber. We know a fiber is made of mainly two parts, core and the cladding. The inner cylindrical layer is core and the outer cylindrical layer is cladding. Refractive index of core is N1, refractive index of cladding is N2. We also know always N1 is greater than N2. Here, in this single mode fiber, the diameter of the core is 8 to 10 micrometer. So, the core is very narrow. Its diameter is 8 to 10 micrometer, because of which it can support only one mode of propagation of light through it. Hence, it is called as a single mode fiber. Its external cladding diameter is about 60 to 70 micrometer. 60 to 70 micrometer. Now, refractive index profile. What is the refractive index profile? It is a graph of radial distance versus the refractive index. Radial distance versus the refractive index. So here, this stands for refractive index of core and this stands for refractive index of cladding. Since there is a sudden increase of refractive index from cladding to the core, here the refractive index profile takes the shape of a step. It takes the shape of a step. Hence, it is called as a step index single mode fiber. Means step refractive index single mode fiber. If you come to ray propagation, here, so a laser is the source of light used. For the light to propagate, the light used is the laser. And this type of optical fiber, they are less expensive and they find application in long distance communication system, that is in the case of submarine cable system. But these optical fibers, they are very difficult to splice. So what do you mean by splicing? Splicing means connecting the strands of one optical fiber to the strands of other optical fiber. For that, there exist optic connectors. Those optic connectors are highly costly. So therefore, it is very difficult to splice. So let us go to the second type of optical fiber, that is step index multimode fiber. Step index multimode fiber. So here, let us know about the geometry. The diameter of the core here is 50 to 200 micrometer. Since the diameter of the core is 50 to 200 micrometer, so it has got a very large core. So because of which it can support number of light rays to propagate through it, or number of modes of light to propagate through it. Hence, it is called as a multimode fiber. It allows many number of rays to propagate through it. And the external cladding diameter is 100 to 250 micrometer. 100 to 250 micrometer. If you come to the refractive index profile, if you come to the refractive index profile, so this is also step index only. The refractive index profile is step index only. So here also the refractive index profile, it takes the shape of a step. So both the type of fibers, they are of step index only. But the difference what you can see means here core has got a small region. Here core has got there is a very large plane region for the core. Very large plane region for the core. That's all the difference. If you come to ray propagation, so here they use either LED or the laser as a source of light, and it is the least expensive of all the fibers, and it finds application in data links which has a lower bandwidth requirements. Means in the case of computer connections or in the case of short distance communication systems, they use this type of optical fiber. Now, the third one is graded index multimode fiber. Graded index multimode fiber. It is also denoted as green. It is also denoted as green. So here multimode fibers are of two types. One is a step index multimode fiber, other is a graded index multimode fiber. That is based on the refractive index profile only. Multimode fibers are classified into two types. One is a graded index multimode fiber, other is a step index multimode fiber. Now you can see the geometry. Observe the geometry. This geometry is same as your step index multimode fiber. There is no change in the geometry of the fiber. Okay. Only there is a change in the refractive index profile. Here the refractive index profile is step index, but here the refractive index profile is graded index. That means, so core has got a concentric layer of refractive index. Core has got a concentric layer of refractive index. That means, so core has got the refractive index more at the center, and as you move away from the center, the refractive index decreases for the core. Refractive index decreases for the core. But so cladding refractive index is uniform. Cladding refractive index is uniform. So this is the major difference. So core has got more refractive index at the center. As you move away from the center, the core refractive index will go on decreasing. Now, if you come to the ray propagation, it uses either laser or LED as the source of light. And here you can see, so there is the light ray propagation is in the form of concentric layers only. So in the second case, the light ray propagates in the zigzag pattern, whereas here it propagates in the concentric layers only. Now, so where do they find the application? These type of optical fibers, they find application in the telephone trunk between central offices. In the telephone trunk between central offices. So these are the three types of optical fibers. Step index single mode fiber, step index multimode fiber, and graded index multimode fiber. Let us go to the next topic. So that is, let us go to the next topic, that is attenuation. Attenuation, or it is called as the fiber loss. Fiber loss. What do you mean by attenuation? The power loss suffered by the signal when it propagates through the fiber is called as attenuation. It is the loss in the light signal as the light propagates in an optical fiber. That is called as attenuation. It is also called as fiber loss. As the length of the fiber increases, even the loss in the light signal will also increase. So here there are three types of losses, three types of attenuation. So what are the three types of losses? There may be loss in the light signal due to the absorption losses, or due to scattering losses, or due to radiation losses. Now let us study one by one. First one is absorption loss. So in this case, as we know, I'll show you one diagram here. See the ray propagation diagram. This one. See, so this is an optical fiber, right? As the light signal, we know light is consisting of photons. As the light propagates inside an optical fiber, nothing but photons are traveling inside an optical fiber. These photons may be absorbed. It may be absorbed by the impurities present in the silica glass of which the fiber is made of. Or else, assuming that there are no impurities in the silica glass. In the silica glass, assuming that there are no impurities, the fiber itself has a tendency to absorb the light energy, has the tendency to absorb the light energy, however small it may be. It may be. That is called as intrinsic absorption. Now just keep this diagram in the mind so that I can explain here. I can explain here. Yeah. So absorption losses occurs in two ways. One is absorption of photons by the impurities. Second one is intrinsic absorption. Let us go with the first one, absorption by impurities. So let us assume that the fiber is made of either plastic or glass. So let me say there are impurities which are present in the silica glass of which the fiber is made of. As the light signal passes into the optical fiber, so those impurities can absorb this light energy. That is one type of loss. Second one is, if you assume that there are no impurities present in the silica glass of which the fiber is made of, then the material itself has a tendency to absorb the light energy, however small it may be. So that is called as intrinsic absorption. Intrinsic absorption. So whatever may be, it is a loss in the light signal. This is called as absorption losses. If you come to scattering losses, see, so this is an optical fiber where light is traveling inside the optical fiber in the form of photons. Now what happens as the light propagates inside an optical fiber? These photons get scattered. Because of the sharp changes in the refractive index of the glass. Over the distance traveled, so what happens? Photons get scattered. When once photons get scattered, in all the probabilities, the photons, they come out of the fiber. So no doubt there is a loss in the light signal. This type of scattering is there, no? It is same as Rayleigh scattering. What is Rayleigh scattering? In the case of Rayleigh scattering, the scattering efficiency is inversely proportional to the fourth power of the wavelength. Scattering efficiency is inversely proportional to the fourth power of the wavelength. Means a light of very small wavelength, can get scattered very much efficiently. 4 times lambda is decreasing means 4 times scattering efficiency will be increasing. So that type of scattering here it will take place. Means if you are using a light of very small wavelength, if there is a scattering loss, then scattering will be more. No doubt there will be more loss in the light signal. That is a other type of loss. Third one is a radiative loss or radiation loss. Radiative losses are of two types. One is macroscopic bending, second one is microscopic bending. What do you mean by radiation loss? Means it is a loss due to the bending of the fiber. The bending of the fibers or bending of the cable is called as radiation loss. So there are two types of bends or bendings, macroscopic bending or microscopic bending. What is a macroscopic bending? Means they are the bends with radii much larger compared to the fiber diameter. Compared to the diameter of the fiber, they are the bendings having larger radii. That type of bends are called as macroscopic bends. Example, it occurs while wrapping the fiber on a spool. If you wrap a fiber on a spool, okay, so wrapping diameter will be more than the diameter of the fiber. Then it is getting bent. That means there will be loss in the light signal. Or turning a fiber around a corner. If you go on turning a fiber around a corner, so what happens? The turning diameter will be more than the diameter of the fiber. So hence there will be bending will be more. Okay. So because of that, there will be loss in the light signal. So this is what macroscopic bending. If you come to microscopic bending, so microscopic bending occurs due to the non-uniformity in the manufacturing of the fiber. So because of which it leads to the loss in the light signal. Microscopic bendings or the small scale bendings that takes place at the core cladding boundary. So these may occur due to the non-uniformity in the manufacturing of the fiber. See, we know this stands for the boundary between the core and the cladding. If the boundary itself is not right, if there is a bending in the boundary itself, then the light will not undergo total internal reflection. There may be some leakage of light. So hence there is a loss. So these small scale bendings which are occurring at the core cladding boundary are called as microscopic bends. So now let us find an expression for attenuation coefficient. Attenuation coefficient is denoted by alpha. Alpha gives you the net loss for the fiber. Okay, there are three types of losses: radiation loss, scattering loss, and absorption losses. The net loss for the fiber can be calculated by a factor called as attenuation coefficient. So let us know about this attenuation coefficient. We know by the Lambert's law.